So here is the first example of direct collisions. Two spheres of mass 4 and 8 kilograms are at rest along a flat plane. The lighter sphere is then struck and collides with the stationary heavier sphere at a speed of 12 meters per second. If the collision brought the 4 kilogram mass to rest, find the speed of the second sphere after collision and the coefficient of restitution between the spheres. So usually the problem solving approach for these is you do your conservation of linear momentum first, and then you do Newton's law of restitution. That's usually the best way to go about it. So, given that, I want you to try this problem, and when you're ready, come back for the solution. So here's a little diagram of what's actually going on. We have our 4 kilogram sphere moving at an initial speed of 12 meters per second to the right, I've defined as positive, and the initial speed of this second one is 0 because it starts stationary and it hits off at v2. And of course, this one comes to rest as a result of the collision. So its final velocity is 0. So the conservation of linear momentum first, we have m1 times u1, which is 4 by 12, plus 8 times 0 is 4 by 0. So this, or this final one rather, plus 8 times v2, which is the velocity of this sphere. So after solving, we get the velocity is 6 meters per second. Now, of course, you don't actually need to use Newton's law of restitution here, but it's always safe to do so. So v1 minus v2, so 0 minus 6, is minus e by 12, which gives the coefficient of restitution e equals a half, which kind of makes sense, because this one goes, transfers half of the velocity over to this. The rest of it is transferred into other forms of energy. But from here, it should somewhat make relatively intuitive sense, or at least if the imagination part of it doesn't make sense, hopefully the mathematics part of it does.